our webinar today. Yes, I see we have people starting to come in. So while people are entering our webinar, so I'll allow you to introduce the webinar for a bit. So in this webinar, we will learn how DestinE can transform renewable energy forecasting through one of the DestinE Platform use cases, the Destination Renewable Energy, or DRE project, and their hybrid renewable energy forecasting system. So as the globe warms at an unprecedented rate, the push towards sustainable future has never been more urgent. The DRE project offers a novel approach to digitizing solar and wind energy production through HYREF. So this webinar will explore how it leverages advanced data sources, including satellite observations and digital twins, to enhance the accuracy and reliability of energy forecasts. This webinar will also explore the future of the HYREF in the DestinE platform and how it can have a future impact on the renewable energy industry. Just a note, we will take questions at the end of this webinar through the Q&A tool. So you'll find that in your functionality bar for Zoom. So, but I recommend you to please keep your questions a little bit until the end, or at least until the end of each presentation. So please wait just in case some of your questions are addressed in later slides. I'm Rob Carrillo, and I'm the lead for the communication and events at the ESA DestinE Use Cases project, and also the lead editor for the DestinE editorial board. And I will be your co-host today, but I'm also joined by my other co-host, HYREF from the National Observatory of Athens, who will be doing the introduction. So, HYREF.
Thank you, Rob. Thank you, dear colleagues. I'm really excited that I have the honor today to open this webinar. I'm HYREF. I'm Research Director of the National Observatory of Athens and the Director of the Beyond Center for Earth Observation Research and Satellite Remote Sensing, which is a research unit of the Observatory of Athens. We are leading as National Observatory of Athens this very key consortium that is leading the Destination Renewable Energy use case. And thank you very much for attending this workshop. I'll give you a very brief introduction of who are the partners and what we're supposed to do in this project and what is the expertise actually and the skills of each one. And of course, then, in the following of this webinar, you will be able to see exactly what we are doing and how much excited we are by developing this very innovative service on the Destination Earth platform. So as National Observatory of Athens, I mentioned already, we are a research institution and organization. We are dealing with big Earth observation data and cloud computing facilities, but at the same time, we are exploiting big data for addressing priorities in thematic areas, one being the renewable energy resources. So in this specific consortium, the National Observatory of Athens is providing data, at the same time IT capability, but of course, all our expertise in the development of models for solar energy nowcast and short-term and long-term forecast. Our partner, Nora Innovation, is leading the task for software development, which is based on key expertise in the creation of artificial intelligence and Earth observation cutting-edge information technology for the derivation of products and services. Our partner, WEMET, is leading the wind energy production task of Destination Renewable Energy use case, relying on long-term expertise in research, development, and operational services for atmospheric modeling and weather forecasting. And last but not least, our partner Quest Energy is among the leading actors in the renewable energy sources sector, and especially in the development, construction, and operation of renewable energy stations and power plants. And it is acting as the key end user in our consortium, actively participating in the co-creation of the Destination Renewable Energy use case. By this, dear colleagues, I would like to give the floor to the next speaker, once again as coordinator As a person that has strongly pushed towards the development of this innovative service on the Destination platform, I would like to really thank you for your attendance, and of course, feel free to have an open discussion and let us know your questions or needs for clarification about the specific service, which we expect by the end of this use case scenario to be a scalable, large-scale application, expandable to many different, parts of our globe. Thank you very much for your attention. And of course, I would like now to give the floor to the next speaker of our webinar. Thank you.
Thank you, Haris. I'm Stelios Karatzis. I'm going to continue with presenting the challenge and the motivation about this project. I'm working in the World Aviation Center in Switzerland and collaborating with the National Observatory of Athens for this project. And the main challenge for this is our climate, the mitigation of climate change towards that is addressed from global and international initiatives. And these initiatives point out clearly that renewables will play a key role in the future. As an example, the United Nations Agenda for Sustainable Development, and especially the development goal number 7 that talks about ensuring universal access to affordable, reliable, and modern energy services. And more importantly, the increase of the share of the renewable energy in the global energy mix. So this project starts from addressing these kind of challenges. Then, of course, the Paris Agreement that talks about strengthening the global response to our climate change, and the European Green Deal, which, as you see with here, talks about that the production of and use of energy accounts more than 75% of the EU greenhouse gas emissions. And the main message here is the decarbonization of the energy system is critical towards the 2030 climate objectives and goals. And one of the priorities is the energy efficiency and development of the power sector based on largely on renewable sources. Next slide, please. Here I have some numbers, and first in the top left, you can see some positive and optimistic numbers that 135 countries have renewable energy targets, 156 countries have regulatory renewable power policies. But you can see also that for the energy and power generation, solar, and wind, and hydropower are the ones that will play the most important role now and in the future. And on the right side, you can see the evolution of renewable energy targets, and all these colors are different legislation of the EU that starting from 2009, pointing out 22% of renewables in the energy mix by 2030. And then there was an update, 2014 up to 27, 2018 up to 32, 2021 up to 40, and the last one, 2022, the Repower Euro plan is talking about 45% of renewable energy in the energy mix by 2030. So all this, next slide, please. All this here is a summary about benefits, needs, and gaps. And of course, societal benefits has to do with worldwide interdependence of conventional energy production. Energy and use of energy have a dramatic impact on global warming, and improved forecasting is crucial to the integration into electricity grids and power plant operation in the energy market. So clear needs are weather data archives, for site modeling, weather forecasting in different time frames, climate analysis and long-term variability of different parameters, and of course the data needs of solar, wind, atmospheric, land use, and other parameters that are needed for all these models and forecasting models to run. And the gaps are till now there are different data sources that are difficult to handle at some points. The user involvement in product definition is currently, let's say, partly missing. There are delays in accessing the near real-time data that are very crucial for real-time forecasting of solar and wind. The handling of large data amounts, especially when we talk about satellite data, it's a problem. And the spatial and temporal coverage is not optimized for energy needs. And also, there are some issues also about standardization. Next slide, please. As an example, yes, we can go forward. And this is the model that, well, the solar model that part of this project was building. This model has been created and developed during the last decade from different EU projects that you can see on the left, Geocradle, SAFE, and Eiffel. It uses satellite data, models, and in situ platforms, and in the end, it produces a realistic assessment of solar energy. So global horizontal irradiance in watts per square meter, so theoretical or forecasted solar radiation, let's say. There were different users, but one of the main problems that was addressed was that the problems were the multi-platform data use, the collocation, storage for near real-time data, limitations, and also end-user tailored products. So next slide, please. The answer to this was the Destination Earth and the digital twin and data lakes that were created as a, let's say, one-stop shop for everything. And again, what was needed is the accurate forecasting that supports global transition to sustainable energy, the standardization of forecasting models and the forecasting methodology. And there are a lot of different models that are used. Others are local, others are more regional, and the data inputs also vary a lot. But the Destination Earth and the DES platform provides a unified capability of high-quality global data that, and also the resources that were previously not possible and were sporadic and fragmented for creating such applications for accurate real-time state-of-the-art data and data pools from the platform. And for the next slide, I have just a small introduction about the system that we're going to hear much more after my talk. So all this motivation led to the creation of this HYREF information and renewable energy system that provides precisely daily information through high-quality digital twin forecasts and data. It's efficient through the use of user-tailored forecasts. So you will hear that it's not theoretical solar radiation, the output, but it's actually production from actual users. The resilience about the HYREF, that has a 2-day forecast, contributing to the integration of the existing power grid, and also there are what-if scenarios that we will hear about. And addressing this challenge that I was mentioning is that HYREF aims to provide information for both solar and wind production, for combining different types of renewable energy sources to ensure a steady energy supply. So it's a hybrid system based on both solar and wind data. And it's an ideal system for smaller or larger users in order to understand the use, the selling, buying, or let's say storing their energy. Thank you. In the next presentation, you are going to hear much more details about this HYREF system.
Thank you, Stelios. Thank you very much. We pass to the next presentation, which is about the HYREF platform. What does the application do? This presentation is given by George Koutallieris, representative from Menora Innovation Partner, and Ms. Papachristopoulou Kyriaki from the National Observatory of Athens. Dear colleagues, the floor is yours.
Thank you, Haris. Thank you, everyone, for this really nice webinar. I'm George Koutalieris from Enora Innovation. The company was founded in 2019. We focus on environmental sustainability, agri-food and energy efficiency, and our key focus is on digital transformation in these target markets, merging diverse IT skills, addressing earth observation, AI, and enterprise software architectures for rapid innovation and strategic growth. So this project, this work falls directly within our interests, and it's a real pleasure to me to explain to you the key concepts behind it. It's a system. It is not one solution. It's a system that meets different stakeholders. So we start with a data orchestration layer, where we connect data from energy producers, and we actually have producers in our team, in our consortium. It's Quest Energy, one of the leading companies in Greece in renewable energy production, and in Southeastern Europe. We met with which we are really glad to be partnering, because they are key consultants and data processors of wind energy. So we establish with them automations, API-based automations, to collect data and support this vision of having personalized predictions, as you see later on. Now, the next layer is the modeling, is the orchestration of the models. And definitely we use data from the digital twin and, of course, the DestinE data lake in order to produce weather forecasting and solar radiation forecasting. Based on these inputs, the models provide tailor-made wind energy forecasting and solar energy forecasting. We call this synergetic decision support services, because it is not one size fits all, and definitely it's a system that works together with different data sources, exploiting all the new capabilities that are being made by DestinE. And at the level of observability, at the level of presentation of data, we make use of the core services, something that we demonstrate later on, which core service components we use in order to deploy through Destination Earth, the HYREF software application, very niche software application that addresses the needs of renewable energy forecasting. Next slide, please. So I think, Kyriaki, now is the right time, because it's not an engineering driven, but it was a discussion when we set up this framework, how this idea has been formulated.
Yes, thank you, George. Hello, everybody. I'm Kyriaki Papachristopoulou, a research associate at the National Observatory of Athens. And I will start describing the solar power production forecasting model of the HYREF application. As has already been stated previously by Stelios at the beginning, solar energy forecasting is a challenging task, and it becomes even more challenging when it comes to solar power production forecasting. The idea was to create a model that forecasts the solar power production tailored to the user needs and infrastructure, based on the co-design with the end user, which is in our project is in this use case is for Kinigos site, a PV park of the Quest Energy partner. Next slide, please. Yes, and this in this diagram, the workflow of this model is presented, describing how the solar model output is generated. As a first step, we are using historical data of solar power production from our user, and historical data of solar radiation from Copernicus data that are available in the data lake. A machine learning model is trained once, resulted to an autonomous model which will provide solar power production outputs tailored to the user infrastructure and needs. So this first step is the training step, performed only once, providing the solar model. Then this tailored model is used every time for the inference of solar power production, which is the forecast in this case. Every day, the model uses as input forecasts of solar radiation from digital twin and produces forecasts of solar power production for 2 days ahead with 1 hour time step for the specific infrastructure of our user, Quest Energy in our use case. The idea for this forecasted solar power production output based on the user infrastructure is to include system characteristics and periodic or systematic losses of the specific user. In addition, the digital twin forecasted surface solar radiation is also provided, corrected for the aerosol effect using our model based on radiative transfer simulations. So these are the time series of forecasted data, both of solar radiation and solar power production output, that are visualized by the HYREF application, as you will see in the next slides. So this was for the solar model, and in the same approach will also followed for the wind power production forecasting model. And again, for the training of the model, user data are used as inputs, and for the inference of the model in a daily basis, digital twin forecasts are used as input with a main output, which is displayed by the HYREF application, are the forecasts of wind speed adjusted to the height and forecasts of wind power production tailored to the user needs. And yeah, with this slide, I complete the describing the methodology followed, and I'm giving the floor back again to George. Thank you.
Kyriaki. Thank you so much. Further to this initial, let's say, inspiration and technological and scientific capability, as we move along developing the software application, we need to explain that it was not something that we discussed internally, or it was an idea of an engineer, but we followed the co-creation process. So we used the online Miro tool, and we tried to come up with certain ideas that we felt that within the scope of this application. Actually, in our innovation, one important part of our priority is to transform user and end user ideas and stakeholder idea into software specs. And we have developed a methodology for that. It's called INEA. Practically, it means that we use a Scrum methodology to develop user stories and epics that are directly linked and traceable to this initial idea. So I'll give you an example. As a plant manager, I want end user tailored forecasting data to make informed decisions about energy management. That was a request that have been made by our partner Quest Energy. Among other things, of course. Therefore, we use these concepts and try to follow a really flexible software development process in order to come up with a software application that would appeal to a larger end user base. Next slide, please. Yeah, now if we would like to put in a nutshell the presentation of HYREF, we would say that it's an application that aims to support the digitalization of solar and wind production markets. We provide solar radiation assessment, as said earlier, wind power production assessment, all these under the 2-day forecast target. And of course, we provide production assessment and 2 or 3 day forecast with customizable production KPIs that appeal to the individual producers. So in addition to the forecasting, there are some production parameters that are monitored in parallel. It seems to us that there is a really important interest in this application type, and we are planning for scaling up the application, and we have already started to develop both freemium and premium tiers for the provision. Now, we need to say that the application uses solar and wind resource assessment, using CAMS, solar radiation, and wind historical data to provide statistics, and also solar and wind forecasts. The models require end-user data to simulate energy production. This is a new thing, and this is something that the modeling scientists have been working on a lot in this project. Next slide. I think that's a moment we have been waiting for, and I need to say that this is a use case. This is a prototype, a proof of concept that has started to flesh out as a real application. So what you are about to see is the application as it was in the previous release about a month ago, but we are working on developing and further scaling up the whole application. At this point, it is already integrated with DestinE Platform with respect to user authentication, use the IAM, so the user can enter the DestinE and through that to test the HYREF web app. Please, next slide. This is the standard screen that users provide their credentials. Next slide, please. And this is, for example, the first screen that sees the producer for a specific site. This is the Kinigo site that is related to, let's say, solar production. Let's see a little bit in detail. Next slide, please. As we can see, the way it is structured, it is based on the specific location. So if in the same location we have solar, wind, or other renewable energies, renewables, then a hybrid model can follow a hybrid part of the application in order to provide some integrated forecasts. Now, at this point, we see a 2-day forecast based on the solar radiation model, and we see the power and the solar irradiance, so we see both lines here. Next slide, please. But in addition to that, we see specific KPIs that are very, very important at this period that the plant manager is using the application in order to see the specific. So we have the plant production parameters, availability, performance, efficiency, and we have some historical based on the specific time window frame of that the user sees that. Of course, there is an opportunity to extend this with the wind predictions. This is the case with the wind. We follow a same approach, but different KPIs and different setup depending on the needs of the end users. Next slide, please. Yes, this is the wind production, and again, this is the virtual wind farm that we have used. This is again an innovation of the project. We have the ability to use synthetic data based on real data from our partner WeMet in order to come up with hybrid models and provide hybrid solutions. Next slide, please. So again, for the wind production, we have the specific key performance indicators that pertain to the end users of wind production. So we are talking about a wind production manager. Next slide. So very briefly, this is the stack, the software stack that we are using, both for web application, backend, API, etc. We can go to the next slide. The whole concept is based on API and open system architectures. So we decide on specific data formats for data exchange between systems. Of course, we use specific APIs for all the services, and we register these services in the DestinE platform using the services registration process. We believe that this approach opens a lot of the capabilities to external stakeholders, and it really can prove this approach as very beneficial, and I would say with great market impacts, anticipated market impacts. So next slide, please. Yeah, we need to make it clear that this development would not have been possible without the capabilities that DestinE is providing to us. So as I mentioned, we are using these open architectures to use models, to use data from different sources to collect data from the producers. But without integration with DestinE, then it would not be possible to give these tools, give these services to producers throughout the world. So this is the clear vision. So we are using the integration with the DestinE core components is in progress. We use a common, let's say, issue tracking system, the Jira tracking system, with the DestinE developers in order to monitor the priorities and monitor the progress of this integration in parallel with our own Jira system that we use for the development of HYREF. Now, as far as HYREF software is concerned, I need to say that at this point, we're finalizing the hybrid section, and we are focused on implementing scalability enhancements. APIs for integration with forecasting models and APIs for data collection methods, and with integrating with existing system in REST producers is ongoing. And definitely, we plan to extend the HYREF user management to complement the different billing models and different usage tiers that we envision. So that means that we are fully devoted to scaling up this solution. And for this, I'm really happy to be presenting today with you the progress that we are making in HYREF. Let's see next slide, but I think, Dorella, we arrived, and now I give the floor back to you.
Thank you, George. Thank you, George.
Thank you, Haris.
Thank you, Kyriaki. Thank you for this excellent presentation. We go directly to the next presentation, which is as displayed about the impact of Destination Air and how Destination Earth platform actually is enhancing our HYREF application. And the floor is again back to Kyriaki.
Thank you. Yeah, hello again. And now I will talk about the impact of the DestinE platform, and specifically to answer the question how our use case, and specifically the HYREF application, is benefit and enhanced from DestinE. I believe that a similar question would be why we are not using our resources to develop this application and we use DestinE platform instead. And as a starting point, I have this diagram, which has already George showed before, showing the main architecture of the HYREF. In order to answer this question, showing step by step how DestinE contributes to each of these components, the datasets and models used, and the final application that the user interacts, describing in parallel how HYREF is enhanced by the DestinE platform. Next slide, please. Yeah, so the HYREF software application, as has already been said, will display user data from solar and wind farms in real time for monitoring and decision-making purposes. And in addition, historical data from the user are used for the training of the forecasting models, which have been developed to forecast the solar and wind power production. Next slide, please. Yeah, so the solar and wind power production forecasting models are using data from both DestinE platform's interfaces, digital twin and data lake, for the training of those models tailored to the user infrastructure, as well as for the inference. The whole process and pipelines of the models developed and used are benefit from the data management services of that platform, which I will describe in the next slide. Yes, thank you. So the data management services of the DestinE platform are used for accessing data and applications. There are three main pillars of the data management services: the data workflow service, the data cache management service, and the user workflow services. And I'm showing here as an example the two main tools that we have been used for accessing data. The harmonized data access tool that we are using to access data from the data lake, and the Polytop tool, which we are using to access the digital twin data. Next slide, please. And which is the impact of the DestinE platform, and specifically of the data management services provided from the platform. There is one place that a variety of datasets is available and accessible. It is a great source of historical data, like satellite-based data, for example, Copernicus solar radiation data that we are using for the solar model, and the reanalysis data, for example, HYREF data that are used from the wind model. It is also provided forecasts from the digital twins, and all of these data are available at the same platform, and tools are also provided to access those data. These datasets, this is very important, the fact that are global datasets of the highest quality, with also high spatial and temporal resolution. And all these features of the DestinE platform are enhancing HYREF, and particularly the potential scalability of the application, as will be described later. So next slide, please. Yep, and the final HYREF software application, which is on board the DestinE platform, and it is making available to the user the tailored solar and wind power production forecast. This final application is benefit from the platform management services provided by the DestinE platform as well. Next slide, please. And specifically, these platform management services are listed in this table that I'm showing here, with a very brief description for each one. The identity and access management IAM service, which is used to configure the access to the application. The service registry, which is a catalog of the applications available in the platform. And it is also an entering point for the onboarding of the DestinE platform. There is the dashboard service, which has information about the status and performance of the service. The accounting service, which has to do with the accounting and billing. There is also manuals for every service, and there is a service desk, which is a ticket system for the users. Finally, there is the runtime platform, which is the basis of the overall solution, and it is also related to the security and the scalability of the services. Next slide, please. Yeah, and so all these management services of the platform are important for the implementation and running the application, as well as the application's visibility, accessibility, and sustainability. And next slide, please. With this final slide, I would like to summarize how HYREF is enhanced by the DestinE platform, which are all potential benefits of every future application on the platform. So DestinE platform amplifies the impact of HYREF by reaching a new range of users, connect with other providers and the community. Also, DestinE platform bridges the gap with the users by joining a unique ecosystem of users, including major European agencies and organizations. And finally, HYREF is enhanced by leveraging cutting-edge infrastructure and artificial intelligence solutions. So this was my last slide, and thank you for your attention. And I'm giving the floor, I think, to Thanasis.
Thank you, Kyriaki. Thank you for the nice presentation. And thank you for keeping perfectly the time. The next presentation is given a 5-minute presentation from Thanasis Drivas about the developments for scaling up HYREF so as to have a wider impact. Thanasis, the floor is yours. 5 minutes, please. Then we give the floor to the audience for questions.
Thank you. Hello, everyone. My name is Thanasis Drivas. I work as Earth observation data engineer at Beyond Center of Excellence of National Observatory of Athens. When we discuss about scalability, we refer mainly to 3 fundamental pillars. The first is related to the DestinE's robust data infrastructure, which is a cornerstone for HYREF operations. By accessing a wide area of environmental data, such as satellite data, meteorological data, historical climate records, HYREF can significantly enhance the accuracy of its forecast. Specifically, this integration of comprehensive data sources allows for regional customization and for adapting prediction to specific environmental conditions. Furthermore, this ability to incorporate real or near real-time data from multiple platforms ensures that our models are continuously updated and effectively being used by everyone that is interested. This data integration capability is essential for scaling HYREF effectively, making it adaptable to diverse regional needs and environmental conditions. Next slide, please. DestinE's advanced predictive modeling and scenario testing capabilities are also important for our application. By leveraging DestinE's digital twins, which are highly accurate virtual representation of the Earth system, we can enhance our forecast models for both solar and wind energy. Specifically, this enables us to simulate various scenarios, such as frequent extreme weather events or land cover changes, providing stakeholders with valuable insights into the potential impacts on renewable energy production. In addition, this scenario helps in revising the optimal strategies for integrating energy into the grid, planning new infrastructures, and developing effective climate adaptation and decision-making policies. So these capabilities are crucial for scaling HYREF to meet the diverse needs of users across the different regions. Next slide, thank you. Last but not least, DestinE's high-performance computing capabilities significantly enhance the application's ability to process vast amounts of environmental data, big Earth observation data, with greater accuracy and speed. This computational power is vital for generating reliable and timely energy forecast, and by integrating advanced machine learning and deep learning algorithms and simulation models, the DestinE acts as an enabler of HYREF to conduct complex analysis of weather patterns and environmental changes. The increased computational efficiency provided by DestinE ensures that our application will be able to manage larger data sets and more sophisticated models that are essential for scaling the application to cover broader geographic areas in diverse climatic conditions. Finally, this scalability is a key to expanding HYREF impact and adaptability to different user needs. Thank you, Mr. Kodoes.
Thank you, Thanasis. Thank you very much. I mean, we are perfect in time. We have 10 minutes more for questions and answers. There are already 2 questions already submitted in the Q&A section. I read them one by one. And dear colleagues, please take the floor to reply. The first question comes from Marius Kochman from Nova Space. I read it like it is submitted. With respect to the user requirements you have gathered, are there input data gaps that make it difficult to address the user needs in solar energy forecasting? For example, satellite or in situ data that does not have the spatial temporal resolution required? Dear colleagues, the answer is on your side. Who wants to take the floor? Stelios, Kyriaki.
I'm sorry, Faris, where is this question in the chat? I can see the chat, but
It's on a Q&A section. It's the first question from Marius Kochman from NovaSpace. It's just next to chat button, the Q&A button.
Maybe to make it easier, Marius Koman also has the permission to speak. He can also restate his question and also introduce himself a bit.
Thank you. That is better. Thank you. Marius, the floor is yours.
Yes,
okay,
thank you.
It's clear. The question. Sorry, I couldn't find it in the Q&A.
Okay.
Thank you, Marius. Yes, for sure there are different problems, spatial and temporal, and especially for atmospheric data that some of them have quite high spatial and temporal resolution, some of them are not. That's the simplest question, but if you want to go to more specific details about which data you mean, then we can discuss it.
Yeah, thank you. I was, let's say, generally interested in what your end user might have wanted, what would have been a use case that they would want to see addressed that is not possible with the current data inputs.
The main thing that should be addressed is an accurate forecast of exact production of the exact end user in a period of in a window of 1 or 2 days. That's what everybody would like to have with very good accuracy. So the whole discussion is about how accurate are these products, and the limitations come for the solar part from the estimation of the cloud and cloud properties in a very high spatial resolution for the next 1 to 2 days, which is something that has to do with the accuracy of the numerical weather prediction forecast of the digital twin. About the wind data, maybe Christos wants to add something.
Yes, Stelios. Regarding the user requirements, is the discussion or the second question about the evaluation of... sorry, Marius, could you
Marius,
clarify?
The first one, Christos, the first one, with respect to the user requirements. I understand that Marius is asking whether we included other stakeholders, other inputs, and if there are any problems or that have been addressed that our application tries to solve. Isn't it correct, Marius?
Yes, exactly. So basically, what are the limitations in this forecasting that you have encountered?
Exactly. This is very, very important, very important question, because now it helps us explain a little bit where we stand. We are not presenting a full-blown end solution, but we have started to develop a proof of concept as part of the very few DestinE use cases. And based on this experience, which just started, less than a year, based on this work, has been a lot of work, but many people and many teams, we started to conceptualize a little bit how forecasting can move on. We took the initiative to start with the end users, but keep in mind this is not a survey with large stakeholder groups. I think that would be something interesting to do in the future. But to make a long story short, we try to address the key issues, which is the 2-day forecast and how it could be presented, and what are the personalization, I would say, adjustments that could be made to this forecasting. Is it clear?
Yes, thank you.
Yeah, I think thanks for letting us share a little bit, because it's a new thing for you that you participate, and also for us.
Okay.
Sorry,
Thank
just
you,
to add.
Haris. Yes, please, Christos. Sorry for interrupting.
Sorry, Haris. Just to add something. Even for this short period of we are now working with the data or the this horizon of 2-3 days, we will test as thorough as we can the performance, because as you might be aware, Greece is an area with very complex topographic features, while at the same time there are these land-sea contrasts and fast evolving meteorological systems. So all these features are challenging where you're dealing with wind and solar forecasting. So we expect to have more results as the progress is going on.
Thank you, Christos. Thank you very much. I think we have to go to the next question. It says it's actually asked by Jonas Engels. I do see that Jonas has no microphone, so I should read the question. How do you rate the accuracy of solar forecasts, and do you have any evaluation results yet? Stelios and Kyriaki, I think the floor is yours. And of course, other colleagues too.
Yes, as you saw in the presentation, there are two main outputs. One is the solar radiation and wind speed and parameters that is evaluated based on actual measurements at some test sites that we have during this project. And the second is that since we are aiming for actual production data, then the forecasted production is evaluated based on the actual production of this test, let's say, users that we have in the project. And in this case, it's Quest data, as you saw in the first slide of the presentation.
Okay, can I ask? Oh no, Jonas has no microphone. Jonas, if you have anything needing as a clarification, please write it down in the Q&A. I should pass to the next question. It's from Francisco Doblas Reyes. Can you please, dear Francisco, can you please ask your question? Do you have a microphone available?
Yeah, absolutely.
Okay, thank you.
Thanks very much. I was just wondering, how does HYREF positions itself in the markets? So I'm working in academia, so it's out of curiosity, but I wonder. Well, I'm sure that there is a market for this kind of products, and I was wondering if you have done a market analysis and you have placed the products that the HYREF is delivering in that market.
Francisco, everybody that works in this project knows what exists in the market, and the two main problems, let's say, right now is the accuracy of the forecast, and the second one is the tailored, let's say, products towards a very specific end user. So there are a lot of theoretical forecast of solar radiation or wind speed, and with different resolutions. So using the ECMWF and DestinE Platform and data, we say, or we have to say, that we use actually the most accurate data existing right now. So we don't have any fragmentation of different kind of data in our models. And the second part is that based on what you saw, there is a tailored, let's say, end user tailored based methodology in order to give this exact product that the end user wants. Now, I think that the Destination platform or stamp, let's say, it's a guarantee for something that will be used in the market. That's my comment, but the project is still ongoing, so we'll see about that in a few months or in a year time.
I see also George Koutaleris, who
Yes,
wants to ask.
Thank you. Very, very briefly, I would like to offer a different angle, an additional angle. Many things, Francisco, might exist, and many things might be on paper or models. I mean, we are trying to put together previous research that spans many years back. However, I need to stress as a software engineer and as a product, let's say, responsible for the overall product, let's not forget the user experience and how you increase the visibility to destination Earth. This is a huge priority for us. That's why we engage in users and we try to focus on the specific features that they need to see on the software. So we believe that to make it accessible, to make it usable, and to make it really concise and to the point with respect to energy forecasting and the needs of the energy producers, we try to make a really competitive product. Thank you for your question.
Thank you, George. Francisco, if you want to add anything, please do it now. Otherwise, we go to the next presentation. No, sorry, to the next question, sorry.
Yeah, sure. No problem. It's very nice. Thank you.
Thank you, Francisco. We thank you. And I think we have time for one more question. It's coming from Mansour. Mansour, do you have a microphone? Can you please ask your question? Or not? If not,
Can you hear me?
Okay, please.
Yeah, great. Thank you very much for this forum. Yeah, from the curiosity perspective, just wondering about what would be the forecasting horizon for this HYREF and or for the Destination Earth tool. It's like a couple of days. Can it goes to as long as possible? Yeah, and technical capability and what is currently available.
Okay, thank you.
Sorry for a lot of questions. Yeah.
Okay, thank you. No, it's okay. It's okay. It's very clear. I think we're actually this question is actually has two aspects. One is the scientific, the modeling part, and the technical capability and the platform part. So please, dear colleagues, George Stelios,
yes,
take the floor.
The forecasting horizon is based on the numerical weather forecasting limitation. So it's a few days ahead, like 2 or 3 or 4 days ahead. So it's not a seasonal forecast. And yeah, this specific DRE project is based on the few day forecasting horizon. ECMWF has a very different approach on the seasonal forecast, but it's not included in this DRE.
May I add something, Haris?
Yes, please.
So currently, the operational application we are developing is depending on the digital twin availability, which is right now 96 hours in hourly temporal increment. So we focus on that time framework right now.
Thank you, Christos. Thank you, Stelios. Okay, now, I mean, I don't see any more questions in the Q&A section, but before we close or before I give back the floor to Rob, Diego, and Torella, dear colleagues, dear participants, do you have any questions, any further questions to ask? I don't see any hands raised.
Sorry.
Yes, please.
Yeah, I have one more question. Might be it's missed in my previously. In Destination Earth framework, is there any other projects that you have it for a long term? Not this HYREF, but some other projects.
Sorry, dear colleagues. Who wants to reply to this question?
I'm not sure, but I don't know any projects like this personally.
You know, Destination Renewable Platform, you mean? I don't think so. Dear Mansour, I don't know if you want to clarify something on that more, but or if you got the answer you wanted, please.
No, I think I got the question because as far as the panel is known, it's not available. Then it's not available.
Okay. Thank you, Mansour.
Thank
now,
you very much.
at this point, thank you very much. At this point, I think I give the floor back to the to Diego, Rob, and Dorella for closing the session.
Thank you very much. And thank you very much, everyone, especially for the participants who are here today. Very interesting insights, of course, from this use case. Highly encourage all of you to join our next webinar, which will be Urban Square, Destiny Empowering Urban Resilience Against Climate Change Challenges. And that's next week, July 9, from 11 a.m. to 12 Central European Standard Time. So please join us for that. That would be, for now, the last of the DestinE Roadshow webinars. We actually have 2 more that we're expecting to organize after the summer. But apart from that, if you're interested in the wider Destination Earth initiative, like Mansour earlier, so we have the 3rd Destination Earth User Exchange. Actually, registration is ongoing at the moment. This is on the 15th to the 16th of October, and it's going to be held in Darmstadt in Germany. So thank you again, everyone, for joining. We had participants from over 30 countries, a lot even from outside Europe. So thanks for those who are joining us, even as far as China, Egypt, Morocco, Peru, the Philippines, UK, and the US. So a lot of interest here from even outside Europe. We look forward to seeing you in our next events, and see you soon. Thank you, everyone, and goodbye.
Bye-bye. Thank you. Thank you very much.
Thank you.
Mm.